Hi guys, it's me, Mr. Bertoch, your incredibly handsome science teacher. And in this video, we are going to be talking about weathering and erosion. All right, house-sized humans. So your goal by the end of this video is to understand the forces that are constantly acting together to change and alter the surface of the earth, which is never the same. Even from day to day, it's always changing because some of these forces happen very quickly, although most take millions of years. So if we look at the surface of the moon, you can see, and you can do this, by the way, with a simple pair of binoculars. It's actually pretty neat how much you can see just with binoculars. And I would encourage you to do that. Go take a pair of binoculars and look at the moon. You can see on the moon a lot of craters. And those craters came over billions of years as asteroids and things smacked into the surface of the moon. And the same thing has happened here on the Earth. I mean, the moon and the Earth are next door neighbors. We're literally right next to each other. So if the moon has been smacked around by all those asteroids, probably the Earth has as well, right? That makes sense. Why don't we see craters all over the Earth? Now, there are some. There are a couple that we actually can see. There's a very famous one in Arizona in the United States of America that we can see, but there aren't very many of them. And the reason for that is because the surface of the Earth is always changing due to geologic forces, in particular weathering and erosion, which erases the craters. It's constantly changing the surface of the Earth. Now, weathering and erosion are not the same thing, but they are closely related to each other, and they work together in order to change the surface of the Earth. Okay, so a quick definition, and then we'll talk about each one in more detail. Weathering is breaking down the rock on the surface of the Earth. And there are different ways that that happens. And we'll talk about those in just a minute. But weathering is the force that is constantly breaking down the rocks into smaller and smaller and smaller pieces. That's weathering. Okay. It doesn't move the material anywhere. It just breaks it into smaller pieces, but it leaves it where it is. Erosion, on the other hand, doesn't break pieces down at all, but instead it carries the smaller pieces away. It lets weathering take care of breaking into smaller pieces. And once it's small enough, then erosion comes along and it says, oh, goody. And it picks up the little tiny pieces and it moves them away. It carries them away and leaves them somewhere else. Okay, so that's basically the two forces: weathering, breaking pieces of rock into smaller and smaller pieces, and erosion, carrying those tiny little teeny weeny pieces away to distant places. Now, I said a minute ago, there are different kinds of weathering. Okay, there's different ways that rocks are broken down into smaller and smaller pieces. So let's talk about those. The first one is something called mass wasting. Mass wasting, which is a fancy sciencey term that means basically gravity. Gravity is taking as you can see here, pieces from up high, like on a cliff, and they fall down into these what are called talus slopes, these piles of rubble at the bottom of the cliff. Okay, and most mass wasting occurs little by little A little bit of dust here and a little bit of rock there falls down because of gravity. But sometimes you get these really cool events where a whole bunch will fall at once, such as in a mudslide or a rock slide or a creep. Creep's a little bit slower, but still fast compared to geologic time, where the whole side of a hill slowly over several weeks slides down the side of the mountain. Okay, so that's mass wasting. Another type of weathering is caused by water, and it is called frost wedging. And a frost wedge occurs when it's cold because water has this unique property, and it's the only substance that does this. When water freezes, when it becomes a solid, it actually expands, gets bigger. And so liquid water will creep into the crevice or cracks of a rock, and then it will freeze. And when it freezes, it gets bigger and it expands, and that acts like a wedge. It breaks the rock apart. It forces that crack to get bigger. Okay, and that's called a frost wedge. And then the next type of weathering is biologic weathering. And that is when living things break rock down, such as a tree growing in the crack of a rock, and its roots squirm their way into that crack, and then the tree grows bigger and bigger, and as it does, it breaks the crack up bigger and makes it a bigger crack. Or when animals sometimes dig and break and move rock and earth material around. Okay. Another type of weathering is chemical weathering. This is a very common type of weathering. We see it all the time with caves where, like limestone, is very susceptible to chemical weathering. It will water will creep in, and then it will the limestone will dissolve. And water is a chemical. Okay, we don't think of it as a chemical, but it is. H2O. It's just a chemical. And so it carries out and changes the rock. It creates a cavern. Another type of chemical weathering is a salt wedge, which works very similar to a frost wedge. A salt wedge is when salt crystals form in a crack and then get bigger and bigger and pry out those cracks and make them even bigger. So that's weathering. Again, different ways that rock is broken down into smaller and smaller pieces. And once the rock is in all these tiny little pieces laying all over the ground, then it is susceptible to erosion, which carries it away. And there are two ways that erosion works. One is through water, and the other is through wind. Okay, and so that's pretty easy to understand. Once the pieces are small enough and light enough, if water comes along, it rains, and the water runs across the surface, it's going to push the little grains of sand or rock along and carry them away to some other place. Okay, and wind does the same thing. Although the pieces have to be smaller, water can carry bigger pieces away than wind can. But wind can carry away dust and move it thousands and thousands of miles. And there is also another type of erosion, which is less common, which occurs inside of a glacier. Ice carries huge pieces like boulders away in the form of glacial till, but not, that only happens in certain places in the earth where there are active glaciers. So erosion happens when pieces are moved away from one place to another. Well, that moving from one place to another implies that we have to then eventually set those pieces down somewhere, right? If we're eroding dust and rocks from one place, we can't just carry them forever. The wind can't carry the dust forever. Eventually, it has to set it down somewhere. And same with the water. And we call that deposition or depositing. Deposition, the dust, the rock, whatever, it's deposited, kind of like in a bank, I guess. You set it down and it stays there in its new home. Okay, and common places where deposition occurs are in any place where water suddenly slows down, like water's flowing in a stream really fast, but then it hits a lake. And so now it's all of a sudden it just comes to a stop. It slows down. Well, once its speed slows down, then it can no longer carry the same load. And so all of the dust and rocks and things in that stream fall to the bottom of the lake, and we get a delta that forms, or in the ocean, we get a delta that forms right there. And eventually, if it's a lake, it actually fills up, and all lakes do this. Eventually, over thousands of years, they fill up with deposited debris from further up the stream, and they stop being lakes. They become really shallow, and they become swamps. And then eventually, they dry up completely because they fill up with sediment, and that is called lake succession. Lake succession is when a lake fills up with sediment that is deposited in the lake over thousands of years, and that's the life of a lake. Lakes don't last forever. Eventually, all lakes fill up with sediment and become swamps and then not lakes at all. The ocean doesn't ever do that because it's so big, but these massive deltas form that can span hundreds of miles, where the river has deposited all the sediments that they collected from further upstream. So again, two forces that are always changing the surface of the earth, wiping away craters, carving canyons, changing the way that the earth looks. They are weathering and erosion, and they work together. Weathering is the process of breaking things down into smaller and smaller pieces, whereas erosion is the process of carrying the materials away. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos, and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.